Ding. Okay, so the morning sessions, we will cover the topic of irrigation water management and also the tools for irrigation planning. And for delivering this session, we have with us Shri Manish Sir. Sir is Deputy Director in Irrigation Planning Organization of CWC, Irrigation Management Organization of CWC, in the Irrigation Planning Central में है sir, Central Directorate. North Irrigation Planning North Directorate, and is currently posted at CWC headquarters in New Delhi. Sir is a CWES officer of 2012 batch, and Sir joined Central Water Commission in the year 2014 and was initially posted as Assistant Director in the Hydrological Studies Organization at headquarters Delhi. And upon promotion to Deputy Director level, Sir got transferred to Irrigation Planning North Directorate at headquarters, and since then he is there for a short while. In between, Sir also served in the ISM, that is the Interstate Matters 2 Directorate under Irrigation Management Organization itself at headquarters. And since 2021, Sir is continuously there in Irrigation Planning North Directorate. So with this brief introduction, I welcome Shri Manish Sir to this training program. एंड सर मैं अब रिक्वेस्ट करूंगा आपसे कि आप प्लीज ये सेशन को आगे लेके जाइए प्लीज ओवर टू यू सर
Thank you so much, Saurabh, for the introduction. So good morning everyone. Today we will discuss about the irrigation planning aspects. How do we do the appraisal part of the DPRs which we got from the different agencies like state governments, NWD or other central agencies. So how do we apprise the irrigation planning aspects that we will discuss today. So
एक बार मैं सभी से सर एक मिनट वो मैं रिक्वेस्ट करता हूँ सभी पार्टिसिपेंट से प्लीज अपना कैमरा ऑन कर लीजिए एटलीस्ट आप अपना एक बार शक्ल तो दिखाइए कि हैं कि नहीं ठीक है सर ओवर टू यू सर
okay, so we'll start with the presentation now. So is it visible to everyone?
Yes, sir.
Okay. Okay, now we'll start with the first of all, how do we categorize the projects? Like we got the projects from the state governments. So how do we categorize them? It is based on the CCA, major, minor or medium. If my CCA cultural command area is less than 2000 hectare, then it is called minor irrigation. If CCA is between 2000 to 10,000 hectare, then it is medium irrigation project. If my CCA is more than 10,000 hectare, then it is a major irrigation project. So
sir,
everybody
PPT is not visible, sir.
What?
PPT is not visible, sir.
Okay.
Only just the dialog box is open.
Is it visible now?
Yes, sir. Yes.
Okay. So first of all, the categorization of the projects based on the CCA. If my CCA is less than 2000, then it is minor project. If CCA is between 2000 to 10,000 hectare, then it is a medium irrigation project. If CCA is greater than 10,000 hectare, then it is a major irrigation project. So CCA is culturable command area. It is different from the gross command area. So the out of the gross command area, whatever part is my culturable or on which the cultivation can be done, that is my CCA. So then my gross command area, it includes the other roads or buildings, other structures also. So when we exclude those parts from my GCA, then it becomes my CCA. If anybody has any doubt in between, you can stop me and ask me in between. So how do we appraise the projects in Central Water Commission? So for minor projects, the planning and approval, it is done by central government on its own. Or for medium projects, appraisal is done by the regional offices of the Central Water Commission. And for major projects, we receive here only the DPRs of the major projects only at the headquarters for the detailed organization and detailed examination. And the coordination of all these DPRs or PFRs, it is done by the uh, project appraisal organization. There is PAO, project appraisal organization is there. So they do all this coordination thing. So the state government, they submit the DPRs to the PO, then PO submit the DPRs to the specialized directorate for examination. The specialized directorates, they did all the all the examination, their comments, they submit their comments to the PO, then PO submit the comments to the state governments for their compliance. So that's how this whole process works. So right now we have the guidelines of appraisal of the major irrigation project 2010 guideline. It is the guideline for preparation of the DPRs of the multipurpose projects. So there is two-step procedure. First of all, the state agencies, they have to submit the PFR, pre-feasibility report. Okay, in that report, it is a basic report that the basic planning of the project proposal they submit for the examination. So whenever we receive the PFR in our office, then we examine that PFR, then give our comments or to the PO directorate for the compliance from the state authorities. So after all these PFRs, they are examined. A screening committee headed by Chief Engineer PO is constituted. In that committee, the specialized directorates like hydrology, irrigation planning, cost appraisal, design directorates, these all are part of that committee. It is called a screening committee. So the approval, in principle approval or in principle clearance for the PFR, it is given by that committee only. That in principle clearance is given for the PFR for preparation of the DPR, not for the project starting of the project. They cannot start the project only after the approval of the PFR. So in principle clearance of PFR given for the preparation of the DPR. Okay, the first part is PFR, then they come up with the DPR, detailed project report. In that detailed project report, the specialized directors, they do the scrutiny in a detailed manner. So we'll discuss one by one how do we do the scrutiny in case of the irrigation planning aspects. And after the approval of DPR, then it goes for the investment clearance for funding. Then feasibility, appraisal of feasibility. So what are the irrigation planning aspects we examine for the PFR? So first of all, the features of the project, where is my location, whether the lift irrigation is there or flow irrigation is there, canal or piped irrigation network is there. So basic details we have to check. We don't go for detailed scrutiny at the stage of PFR. What is my GCA, what is my CCA, and cropping pattern, what are the cropping pattern they have proposed, and what is the crop water requirement and water availability. Initially, we don't go for the detailed processes. We look into all these like features of the project and give the clearance to this at the PFR stage. So so after the in principle clearance, so they come up with this DPR part. So now this is the appraisal of DPR. So planning is done to ensure the most effective use of water. Then appraisal of irrigation planning aspects. So basically there are two parts: technical feasibility and economic viability. These two parts, they are checked in the irrigation planning directorates. So in technical feasibility, there are different parameters, and for economic viability, there are different parameters. We will discuss one by one. First, the technical feasibility. So these all are the 8 parameters which we check here: basic planning, resource availability, soil survey, cropping pattern, then water planning demands, total demands. Then we prepare demand table. We'll discuss one by one. So first, the basic planning. So collection of the data and its interpretation. So the very basic thing about the irrigation planning aspects or appraisal of the irrigation planning is the data. So the whole foundation is dependent on the correctness of the data, or from where the data they have taken, the state government agencies. So we have to look into that. If my data is correct, then I will get the correct results for designing of my this project. So we have to look into that, whether the data is from the CWC site data or from other IMD agencies or other agency data. We have to see all these things. So due consideration for various alternative aspects also. Then issues like submergence and the length of the canals, these parts we take into account. Then resource availability, water resources, land resources. So in water resources, we look into the surface water. There is also in our guideline that we have to go for conjunctive use of surface and groundwater also. But here we only focus upon the surface water. When there are insufficient surface water for meeting the crop water requirement, then we look into the groundwater resources also. So in surface water, the assessment based on GND data. So the groundwater availability, it is done by the hydrology directorate. So hydrology directorate, they prepare the yield series or water availability series and give us the 75% dependable yield based on the data they have with them. So first, there are 2 types of projects: storage and diversion, like dams or barrages. So for yield series of dams, 20 to 40 years on monthly basis yield series we require for the appraisal. Or for barrages or diversion structures, other diversion structures, yield series of 20 years on 10 daily basis, because in diversion structures there must be more fluctuations will be there. That's why we go for 10 daily basis. Or for storage structures, we go for only monthly basis. Then comes the groundwater. So conjunctive use of groundwater with surface water in consultation with the CGWB. If state authority propose the groundwater utilization also in the project, so we told them to get it checked by the CGWB also, because we don't have any data or any other thing for the groundwater utilization. So pre and post monsoon groundwater level in the command, they have to submit all these details in the DPR itself. Assessment of total quantum of groundwater, annual draft and available draft for future use. Then monitoring of groundwater levels, that is rising, falling trend of groundwater. So if my command, it lies in an overexploited zone, so then we can tell them that we don't go for the groundwater utilization, because that area is already overexploited. So we have to look into that my command is lying in safe zone, whether it is lying in safe zone, critical, semi-critical, or overexploited zone. So accordingly we have to take a call. Then comes the land resources. So first of all, we have to see the GCA, CCA and land use data from the revenue or village record. So state authorities, they submit to us this GCA and CCA values. So but we don't have any other criteria to check whether this CCA is correct or not. We have to rely on them only. So CCA of project fixed on realistic basis and practical basis. Then intensity of irrigation. So how do we define the intensity of irrigation? So like CCA is my geographical land on which the cultivation will be done. So there could be crop seasons, Kharif, Rabi or Zaid season. So how much is my area is irrigated in all crop seasons? Then we quantify the intensity of irrigation. Suppose my CCA is 100 hectare, and in Kharif I am doing the 100 hectare irrigation, and in Rabi also I am going for the 100 hectare, and in Zaid also summer crop I am going for 100 hectare. So my total annual irrigation will be 300 hectare, and my CCA is 100 hectare. So how much will be my intensity of irrigation? It will be 300%. So that's how the intensity of irrigation is assessed. So annual irrigated area. So I have already told you that the sum of all the cropping seasons irrigated area, that is my annual irrigation. Then soil survey. So my planning will also depend upon this what kind of soil strata is there in my command. So identifying the suitability of soil for irrigation and to know likely behavior under irrigation based on their irrigability classification. So for deciding my cropping pattern, how what means what will be my crops in that particular command area, it will depend on my soil strata also, because if like I have a like shallow soil or sandy soil, so I cannot go for water guzzling crops like paddy or sugar cane, because the percolation losses will be very much high. So we will discourage the use of these paddy crops or water guzzling crops in shallow or sandy soils. So deciding the drainage requirements, reducing problems of waterlogging, salinity, these things we have to look into. Then cropping pattern. The proposed cropping pattern reviewed in the light of soil survey report. That soil survey report will be submitted by the state authorities in the DPR itself. Then high water consuming crops like paddy and sugarcane should be discouraged. That I have already told you that in sandy or shallow soil, we should discourage these kind of crops, water intensive crops. Then existing cropping pattern in command, the food habit and tendency of farmers to grow the crops. So what is the existing cropping pattern, or what are the tendency of farmers in that particular command area? We have to also take into mind these things also for defining the cropping pattern or proposing the cropping pattern at the stage of designing. Then quantity of water available. This factor is also important, because only water intensive in a area where the water is very water availability is very less, we cannot go for water intensive crops. We have to go for the less water consuming crops only. Then comes the water planning. This is the main part what we do here, like in crop water, how to assess the crop water requirement. So state authority, they propose the cropping pattern, like this will be my crops, these crops will I will grow after the project completion. So we have to assess the crop water requirement of all these crops and check whether my available water is sufficient to meet my demand of these crops. So how do we assess these crop water requirement? So there is a term called evapotranspiration. So evapotranspiration, it gives me the consumptive use of the crops or the total water requirement of the crops. So this term includes two things, evaporation and transpiration. So so how do we define the crop water requirement of any particular crop? So there are three parts. Like first part is uh, how much water is required by the crop for building up of their tissues. So first this, then there are some evaporation takes place from the soil in the vicinity of the crop. Then third part is that the amount of water that is evaporated from the plant leaves through their stomatal openings. This is also called as the transpiration process of plants. So these three parts makes the total of evapotranspiration. But the amount of water that is required by the plant for building up their tissues, it is very insignificant. That's why we ignore that part and we consider the other part of transpiration and evaporation. So there is a term called reference evapotranspiration. From that value, we calculate the crop evapotranspiration. First of all, we define the reference evapotranspiration. So how do we define the reference evapotranspiration? The rate of evapotranspiration from an extensive surface of 8 to 15 centimeter tall green grass cover of uniform height, actively growing, completely shading the ground and not short of water. This is a theoretical definition. Then that how do we define and how we calculate these value, I will discuss it later. So there are different methods to calculate this reference evapotranspiration ET naught values. So there are there are different analytical or empirical methods to calculate this ET naught values. So Blaney-Criddle method, Hargreaves method, Christensen formula. But these all methods, they are not in practice right now. Right now we are only going for the Penman-Monteith method and modified Penman method. But these were the methods which were used earlier. But because of the use of less data or giving the inaccurate results, so these methods, they are already obsolete. So right now we are using the modified Penman method and Penman-Monteith method. So this is the modified Penman method. So it has two terms, the radiation term, then an aerodynamic term. So there are many things like net radiation values, weighing factor for the effect of radiation on ET naught, then saturation vapor pressure, actual vapor pressure. Based on these climatological data, we assess this modified Penman method. The other method is Penman-Monteith method. So this method is our guideline recommends both methods, the modified Penman or the Penman-Monteith. But Penman-Monteith method is a more physical method. It also includes the stomatal resistance of the crops which takes place during the evaporation or transpiration process. So it is a more physical method, or it gives more correct results, Penman-Monteith. So right now we also use this method by using this. There is one software, FAO software, CropVet, which calculates these values. So I will discuss it later also. So this is the equation for the Penman-Monteith. It also includes the vapor pressure or psychometric constant. So many factors are there, or it is a very complex method, but we have other different software is there from which we can easily calculate it. So yes, modified Penman method and FAO PropVet software. So I will show you how it looks like. So this is the PropVet software interface. So it is a freely downloadable software. PropVet, it is developed by FAO. So from this software, we can directly calculate the ET naught values. So what do we need to calculate these ET naught values? Minimum daily temperature values, maximum daily temperature values, relative humidity values, wind speed, sunshine hours, and radiation. These, if I know all these values, I can easily calculate the ET naught values by directly putting these values into the software. So how do I get these values, these climatological values of temperature, humidity, wind speed? So so IMD have their own stations where they assess all these values. So these all values are average values of 25 to 30 years. 35, these are all are normal values. 25, 30 years normal. Temperature, minimum temperature, maximum temperature, humidity, wind speed. These all are normal values, like average values of 25 to 30 years. So these values we can get from the IMD. But we have to see that the station of that IMD, it must lie in my command area. So only the data of that station I will put into it which lies in my command area. Okay, so these values I can get from the IMD stations. So these dots you can see on the India's map. So these are also, there is also one software, ClaimVet software, which is also a freely downloadable software. So in ClaimVet software, these dots, they are the station data. So I can easily select the data, or I can easily select these dots values and export this data into my PropVet software by using this ClaimVet data. But this ClaimVet data is old data now. because it only has the data to the 2002 only. So we need the latest data. So that's why we go for the IMD values or IMD station data. So that data is provided by the state government. They have to procure that data from the IMD because it is not a freely available data. It is like they charge some amount for providing this data. But recently we have CWC have the IMO with MOU with this IMD, and we are planning to get all these data of all the stations in the India from the IMD station itself, so that we can directly use these station data in our appraisal part. It is in very like later stage. We'll get this data and we can easily use it. So ET naught we have calculated by using the crop bed software reference evapotranspiration. Then comes the crop coefficient, KC values. So there are two approaches, like single KC approach and dual KC approach. For single KC, there is our guideline is there. From there itself we can easily pick the KC values. For dual KC, there is one software, sim dual KC software, but right now we are not using this sim dual KC software because in dual KC approach, two KC values are used, one KC for evaporation and one KC for transpiration. In single KC approach, only single KC value is used, so we don't bifurcate for evaporation and transpiration. So I'll tell you from where. So table 27 is there in our guidelines. So this is technical series 2 guideline 1984. So from these guidelines, these are the crops, and these are crop development stages, and these are the KC values for different crop development stages. The range is given to us. So if suppose my crop is groundnut, so for initial crop development stage, 0.4 to 0.45 is 0.5 is my KC value. Then from crop development stage, 0.7 to 0.8. Then for mid season, 0.95 to 1.1. For late season, 0.75 to 0.85. At harvest, 0.55 to 0.6. So that's how we can easily use these values or pick these KC values from this table only. So till now we have calculated the ET naught value, then the crop coefficient KC value. Now we will discuss the effective rainfall. How do we calculate the effective rainfall? So effective rainfall is that part of the rainfall that is directly utilized by my crop. So how do we assess this effective rainfall value? So there is a method given in our technical series 2, guide for estimating the irrigation water requirement, technical series. From there itself we can get the effective rainfall values. So I will show you the table from where we can calculate these values. So this is the table. It is not very clear. So these on the left corner, these are the monthly normal rainfall values. Okay, and on this top value, these are the consumptive use values like ET crop values. These are so, and these are my effective rainfall values. Like if my monthly rainfall value is 100 and my consumptive use is also 100, so my effective rainfall value will be 69 only. So 100 will not be my effective rainfall. Only 69 will be my effective rainfall out of 100 value. So that's how we can easily calculate the effective rainfall values by using the normal monthly normal values and the monthly consumptive use values. So crop water requirements of crops, they are estimated using the modified Penman method or the or crop bed software with due consideration of the pre-sowing requirement, transplantation, nursery. So pre-sowing requirement, we have to add also the pre-sowing requirement that I will discuss later also. So till now we have calculated the ET naught, then KC value, okay, then the effective rainfall. So after that we calculate the net irrigation requirement. So what will be my net irrigation requirement? So ET naught multiplied by my KC, it gives me the crop consumptive use. Okay, so crop ET crop. Then I add the percolation losses and subtract my effective rainfall values. That gives my net irrigation requirement. Okay, after deducting the effective rainfall values, then we calculate the field irrigation requirement at canal head. So by applying my field application efficiency, we get the field irrigation requirement. And for calculating the gross irrigation requirement at my headwork, we apply the conveyance efficiency. By applying the conveyance efficiency, we get the gross irrigation requirement values at my headwork. And for the planning purposes, at the stage of designing, because the project is going to be built, so we assume some values, field application or conveyance values we have to assume. So for ponded crops, field application efficiency is 80 to 85%. Ponded crops are like my paddy crops. These are ponded crops. Other non-ponded crops, we go for only 65%. And my conveyance efficiency, these are all assumptions, assumed values. For unlined canal system, 55 to 60%. For partially lined canal system, 65 to 70%. And for fully lined system, it is 70 to 75%. So these values we apply for assessing the gross irrigation requirement. I'll show you table also at the end. Then comes the micro irrigation. So right now we also encourage the state authorities or the farmers to go for the micro irrigation also. So in micro irrigation, there are two methods like sprinkler and drip irrigation. So we directly apply the water into the root zone of the crops. In drip method and sprinkler also, there are the evaporation losses are very less if we compare it with the surface irrigation methods, flood irrigation. So there are too much water use efficiency is very less in the surface irrigation methods. So we opt for the micro irrigation. So this is the table which I have taken from our guidelines. You can very well see here that in surface irrigation and in micro irrigation, the overall efficiency is so much difference is there, around 15-20% difference is there from if we go from surface to micro irrigation. And if we also go for the piped conveyance system, because in canals there are losses are higher. If we like convey the water through the pipelines, so my efficiency will also increase. So around 20% or 25% of efficiency gets increased by using the piped irrigation and micro irrigation. So why we go for the micro irrigation? Because it is an efficient method for water application. So drip and sprinkler. In drip, we directly supply the water to the root zone by the nozzles. And sprinkler irrigation, we have already seen it. The evaporation losses are very less in these methods. So it minimizes the evaporation, and surface runoff is also less, and it is suitable for water scarce regions like Rajasthan or drought prone areas. We can go opt these methods. Then comes the other benefits or other demands of the project proposal, because right now the project proposal, they are not only the purely irrigation, the domestic water, industrial water demand is also there. So we assess these domestic and industrial water demands also. So as per the national water policy, drinking water needs has been given the first priority. Therefore, provision for the same in the project has to be made. So how How do we calculate the drinking water needs? So by projecting the population for 25 years, 25 or 30 years, how much will be my population and how much is my per capita demand right now. So that's how we calculate the domestic water demand. Then industrial water demand also, the same way industrial water demand is it is submitted by the different industries, whether there is thermal industry or any other chemical industry is there. So they give their demands to the public, state governments, and the same is proposed under the project. So based on these, all these demands, irrigation demand, drinking demand, or industrial demands, we prepare the demand table that shows the total water requirements. Okay, for 10 daily water requirement for diversion structures and monthly water demands for the storage structures. So this is how the demand table for a command for a particular project is prepared. So these all are crops. These are crop water requirements. So total water demand. So here it is only the irrigation demand. If we have the industrial and drinking water demand, we will add up those demands also. Then the canal capacity. Then how do we calculate the canal capacity? So once my demand is finalized, so based on my peak demand, I calculate my canal capacity and also 10% extra capacity for rush irrigation, for like my monsoon floods, or in case of any if in case of any flood incident. So this 10% extra capacity is also added into the canal capacity. Like peak 10 daily irrigation demand. So if suppose this is my peak 10 daily irrigation demand, so I will add up the 10% for rush irrigation, 11.3. Then if my project is also having the drinking water demand, so that is my 0.20. So to total peak 10 daily demand will be sum of all these three values. So my canal capacity will be based on my this total peak 10 daily demand. Then comes the working tables. So we have till now we have calculated my demand, irrigation demand, drinking water demand, industrial demand. Okay, water availability I have with me, which has been approved by the hydrology directorate. So I have my water availability, I have my demand also. So I have to match both these demands and water availability to get the success of the project. This is the most important part of the project, technical feasibility of the project. We have to check the success of the project, whether my water availability is matching with my demand or not. So based on these working tables, we define whether the project is feasible or not, whether the project is success or failure. Okay, so these tables, they are prepared on monthly basis for storage schemes and for 10 daily basis for diversion schemes. So this is how we prepare the working table. So this is my FRL and MDDL value, my MDDL capacity, and the storage capacity at FRL. My year for this, we have to run the whole this simulation for the 25 to 30 years period, for which my water availability series has been approved. So I have taken example of this 1 year, 1990. So June month, these are the 10 daily demands. June, first 10 daily, second 10 daily, third 10 daily. Then from elevation area capacity curve, we can find out the levels, areas, and capacities. So how do we start this simulation table? So in this, for starting this simulation table, we have to assume the my dam at the MDDL level. So for starting, we assume the dam that my dam is at MDDL level from starting. That then there comes the inflow. These values we get from the water availability series from the hydrology. Then my total water available. This is total water available, like my capacity plus my inflow minus my demand at or capacity at MDDL, because I cannot go below my MDDL. So I have to restrict it to MDDL level only. So this is the total water available. Then my different demands, drinking water demand. So I have to check met or not. This is so I will place success or failure. So first priority I have to give it to drinking water. So first I have to check for drinking water whether my water is available to meet the drinking water demand. If it is available, then it is a success. And then after meeting the drinking water, then I will go to next demand for irrigation. If available water is more than the irrigation demand also, then there it will be success. Then evaporation is also taken into account. So this evaporation data, you have to take it by the IMD observatory, or some stations will be there. Sometimes state authorities, they also have their own stations where they measure the evaporation values in the command itself. So those values we can use to identify the evaporation evaporation values. Or if they don't have any station, then they can take the values from IMD also, because they have their observatories, evaporation observatories in the whole country. So from evaporation we assess this evaporation values, and this is the final capacity. So final capacity, how I will calculate the initial capacity plus inflow minus evaporation minus my drinking demand minus my irrigation demand. So this will be my last value after deducting all these demands. So this final capacity value will be my first value in the second iteration. So that's how this whole simulation will run for 25 years. So this 51.2652 will come to next 10 daily 51.625. So then again the inflow will be added and all demands will be subtracted. Then it will again come at 55.96. Then this will be my next next demand, starting demand. That's how this whole simulation table will run for 25 to 30 years. So then how do we assess the success or failure? So these are the success and failure values. Okay. So if my table, if it fails for drinking water demand, or it is not able to meet the drinking water demand in any 10 daily or any in single 10 daily, then it will be a failure year. Like in 1990, if there is only one single failure in whole year in meeting the drinking water demand, then that year will be a failure year. Okay, so that's how we calculate the failure years or success years. So at the end, we calculate the how many failure years are there out of the total number of years, and we calculate the success. How many are my success years and how many are my failure years. So for drinking water, my success should be 100%, else my project will fail. Or for irrigation, my success rate must be 75 or more than 75, else my project will fail. Yes, for domestic demand, first priority is checked, and 100% success rate should be there for the for meeting the drinking water demand. For irrigation water demand, 75% success rate is required as per the guidelines. Okay. If my project is meeting both these criteria, then the project is success project, else the project will be fail. Then higher success rate for irrigation is acceptable. However, economy demands the success rate should preferably be close to 75. Yes. So the minimum requirement for a success of the project for irrigation is 75%. So it is better that it is close to the 75%. If it is more than 70, 80, 90%, then it is not economically preferable. It is like it is feasible or it is success because it is greater than 75%, but it is not economically preferable. Then we also look into the minimum E-flow requirements also. E-flow requirement for ecological flow consideration. These are also taken into account in the working tables. One example I will show you here. Excel sheet is visible to all of you.
Yes, sir.
Okay. So this is the working table which we have prepared for the UJ multipurpose project. The project is situated in the J&K, Jammu and Kashmir. So we have prepared this working table. So in this particular project, power component was also there. So irrigation, power, drinking water, these three components were there. So we also, and E-flow was also part of it. So we considered all these things. So इस प्रोजेक्ट में क्या था कि जैसे इनफ्लो था हमारा, फिर ये ई फ्लो वैल्यूज थी जो कि मैंडेटरी है, ई फ्लो आपको रिलीज करना है. So there was one Bilawar irrigation demand was there. It was in the upstream of the dam. Then these are the releases of through the powerhouse for generating that much amount of water. These releases are also required, and these were my drinking, industrial or irrigation demands were there. तो ये हमने इसमें क्या किया था कि जैसे जो अपस्ट्रीम का है वो तो हमने यूटिलाइजेशन है उसको पहले ही सब्ट्रैक्ट किया था जो हमारा इनफ्लो आ रहा है. फिर हमने इसमें कंडीशन लगाई थी कि हमें पावर हाउस से जो रिलीजेस आएंगे, अब किसी किसी कंडीशन में मेरे पावर हाउस के रिलीजेस जो है वो ज्यादा है मेरे इनफ्लो से, कभी कभी मेरा इनफ्लो ज्यादा है पावर हाउस के रिलीजेस से, और मेरी इरिगेशन डिमांड जो है वो भी ऐसा ही है, कभी पावर हाउस से ज्यादा है कभी कम है. तो जो मेरा पावर हाउस से रिलीज होके पानी डाउनस्ट्रीम में जाएगा, उसके बाद ही बैराज से पिक करके वो कैनाल्स के थ्रू मेरी कमांड में जाना था. तो जब रिलीज होने थे पावर हाउस से वो पानी आई कैन ऑल्सो पिक एट द बैराज एंड कन्वर्ट इट टू माई कमांड्स. तो इसमें कंडीशन इस तरह से लगाई थी कि अगर मेरा पावर हाउस का जो रिलीजेस हैं वो अगर मेरी इरिगेशन की डिमांड से ज्यादा है तो मेरा वो कन्वे करेगा, मतलब वो मेरी इरिगेशन की डिमांड फुलफिल हो जाएगी. लेकिन अगर मेरा पावर हाउस के रिलीजेस कम है मेरी इरिगेशन की डिमांड से, तो उस टाइम पर मुझे एक्स्ट्रा पानी मेरे डैम से भी निकालना पड़ेगा टू फुलफिल दी माय रेजिडुअल डिमांड, इरिगेशन डिमांड। और ई फ्लो रिक्वायरमेंट भी था। उसके बाद भी जैसे मान लो मेरा कुछ कहीं कहीं पे मेरा जो रिलीजेस थ्रू पावर हाउस है वो मेरी ओवरऑल डिमांड से ज्यादा है, तो मेरी सारी डिमांड मीट होने के बाद भी कुछ पानी स्पिल करेगा। तो वो स्पिल जो पानी किया, वो पानी अगर मेरा ई फ्लो से ज्यादा है, फिर तो मुझे ई फ्लो के लिए पानी निकालने की जरूरत नहीं है। लेकिन अगर ई फ्लो से कम है तो मुझे जितना वो डिफरेंस है वो भी मुझे अपने डैम से और सप्लाई करना पड़ेगा टू मीट द ई फ्लो रिक्वायरमेंट। सो दिस इज हाउ हमने ये पूरा निकाल के दिया था वर्किंग टेबल। सो कंडीशन टू कंडीशन बेसिस होता है, मतलब इसमें कुछ भी ऐसा फिक्स्ड नहीं है दैट दीज आर द ओनली डिमांड्स और यही बस इरिगेशन है इस तरह से। तो हमें केस टू केस बेसिस पर ही वर्किंग टेबल प्रिपेयर करना पड़ता है, दैट what are my upstream demands, so what is my e flows, then if there is any power component or is there or not. Okay. So ये है, this is the actual demand table which we have prepared for same project, which project. So that's how we calculate the demands for each crops: paddy, pulses, sorghum. This is how we. So ET naught values we have calculated from the crop bed software. Then KC values we have taken from that guideline for different crop development stages. So this is, you can see that 1.1, 1.1, then 0.95, 0.95. So for different stages, different KC values. Then we calculate the ET crop by multiplying ET naught by KC. ET naught, ET crop values, crop evapotranspiration. So in case of paddy, we also add the transplantation and nursery values. Or in other crops, pre-sowing 75 mm. In all other crops, we add up the pre-sowing values like 75 mm as per the guidelines. But for the expanded crop, nursery and transplantation, these two values they are added. So in case of paddy crop, percolation losses are also there because it is a standing water crop. So उस जो particular command था हमारा JNK में, that was there was a sandy soil. So we have considered the 6 mm per day percolation losses. So these are the losses. So 732, you can see that 732 percolation losses here, mm. So it is very huge value. So we also told them to not go for these crops, paddy crop, in that particular command. But उनका कहना था कि वहाँ पर farmers जो हैं वो they usually go for these crop only. आप जो भी मतलब उनको बोलो, लेकिन वो paddy crop ही grow करते हैं, तो इसलिए फिर हमने paddy crop को ही consider किया था इसमें. So month wise ET crop values कर लेते हैं, उसके बाद में effective rainfall values based on that table, consumptive use and the normal rainfall values, effective rainfall values calculate कर लेते हैं. Then net irrigation. Net irrigation is my ET crop plus percolation minus my effective rainfall. This is my net irrigation. Then field irrigation. For ponded crop, 85% is my field application efficiency. So field irrigation requirement we calculate. Then the gross irrigation. So for conveyance, so they have proposed for line canal. So we have considered the 70% canal efficiencies. So by applying the 70%, we calculated the gross irrigation requirement. So that was the gross irrigation requirement for paddy crop. So in the same manner, we have calculated the gross irrigation requirement for all other crops. So this ये जो हमने किया है ये सारा हमने एक्सेल शीट पर खुद से किया है, बट वी कैन ऑल्सो गो फॉर क्रॉप बेड सॉफ्टवेयर. So by directly putting all these values, we get the ET naught values from the crop weight software. It also calculates the effective rainfall values. By putting the rainfall, normal rainfall values, it assesses the effective rainfall values. And also it also calculates all the like irrigation requirement for all the crops. हमें बस इसमें क्रॉप पीरियड बताना होता है उसमें, और केसी वैल्यूज फीड करनी होती हैं. उसके बेसिस पर ही इस सब क्रॉप्स के लिए क्रॉप वाटर रिक्वायरमेंट भी कैलकुलेट कर लेता है, ऑल क्रॉप्स. बट इसमें ऐसा है कि ये क्रॉप वाटर रिक्वायरमेंट तो ये मतलब असेस करेगा, लेकिन प्री सोइंग रिक्वायरमेंट वी हैव टू एड इट अप. अलग से हमें प्री सोइंग रिक्वायरमेंट ऐड करना पड़ेगा टू कैलकुलेट द टोटल ग्रॉस वैल्यूज. So this is how we calculate these values by crop weight software. So that's all for irrigation planning part. So we'll discuss the other part of the assessment, like we discussed the technical feasibility part. So economic viability we'll discuss in the next lecture. Saurabh? So okay, then we'll discuss the next part of economic viability at 11:30. Thank you. Hello.
Okay, so we break for a short tea break now, and we will resume the session at 11:30. So I request all the participants to please remain connected and join the session back at 11:30. Sir. ठीक है sir, you can start.
Okay. So in the last lecture we discussed about the irrigation planning aspects. So how to find out the ET naught values, then KC values, effective rainfall, then net irrigation requirement, field irrigation requirement, then gross irrigation requirements. How do we assess the working tables, success rates? So is there any doubt? You can ask me. तो सबको सब समझ में आ गया? ठीक है, no issues. So for this appraisal of irrigation planning, so most जो biggest constraint है जो हमारे पास अभी आज के डेट में, वो है data constraint. For finding out the ET naught values, we require the climatological data. So like minimum daily temperature, maximum daily temperature, sunshine hours, wind speed, relative humidity. These all the data we need to calculate the ET naught values. So, and this data is not freely available, and this data is so much difficult to get. So most of the projects, they get stuck because of the availability of this data. So that's, so right now we have that MOU with the IMD, and we asked the IMD for all these stations, data for all these stations, climatological data, to share with us, so that we can directly, we have directly access to all these data, and we can get these ET naught values. But currently we don't have this data. They have not shared with us. But normal rainfall data we have with us. They have shared the only normal rainfall data, like daily normal rainfall data. But other data they have not shared right now. And one more thing is that we have also planned for one irrigation planning software in consultation with the SMD Directorate. So we are planning to have a irrigation planning software. By using that software, we can do the whole irrigation planning process by giving the input data, like the ET0 values, working tables. We can get all these values by putting the input data in that software. So it is in the very early stage, but we have already given that mandate to the SMD. So we hope that that software will be get ready by in around 6 months or 7 months. Then we don't need these all Excel sheets or like that. So by using the input data in that software, we can easily get all these values from that software only. Okay, then we'll proceed to the other part, the economic viability. The PPT is visible to everyone?
Yes, sir.
No, sir. It is not
No.
visible.
Okay. Hello. Now is it visible?
Yes, sir.
Okay. So we will discuss about the economic viability part. So we first check the technical feasibility, then we check the economic viability. So I'll give you brief background of this. What is the criteria right now we are following for checking the economic viability? So in 1958, the Planning Commission initiated the studies for the project to assess the overall benefits of the project. So the studies, they were completed in 1961, and it showed that the total benefits, they are far more than the financial returns which we get from these projects on yearly basis. So that committee recommended the use of BC ratio for assessing the feasibility of these projects. And at that time, only direct benefits they were considered. Indirect or secondary benefits, they have not been considered for the total benefits assessment. So the benefits, it was to be worked out as the difference between the total value of the agricultural production and the cost of cultivation after the value of agricultural production and cost cultivation before the irrigation, like pre-project and post-project. So this was the benefit part. Cost was comprising of annual interest on capital, depreciation, and O&M charges. Then in 1964, there was one more committee suggest ways and means of improving the financial returns, recommended that economic benefit criteria should be adopted for sanctioning the irrigation projects instead of the financial criteria. And the government also accepted this BC ratio criteria. Then Irrigation Commission 1972, they have also observed that the economic benefit criteria is more suitable than the financial return, because earlier the internal rate of return was methodology was used, but after that this BC ratio concept came. So in the BC ratio, benefits represents the total gains accruing from the project, and the cost represents the expenditure involved in producing them, all in terms of current values. So the Irrigation Commission, it also recommended the continued use of BC ratio. So right now the existing practice is also where we assess the BC ratio. So a working group under the chairmanship of CPO CWC. It was set up in 1999 and they have updated the guidelines preparation of DPR 1980. So working group submitted its report in 2000 and the finalized report of that the guidelines for preparation of DPR irrigation multiplier plus projects 2010, which is also right now we are following the same guidelines. And the same guidelines gives us the procedure for calculation of the BC ratio. So earlier the only irrigation benefits were there, but in 2010 guidelines, benefits due to drinking, industrial water supply, pisciculture, animal husbandry, hydropower, catchment area treatment, canal, bank plantation, reservoir territory afforestation, they have also been added up. Okay. So appraisal of DPR in respect of economic viability is one of the important feature. Essentially, it involves the investment decision based on the cost estimates, because we have already checked the whether my project is technically feasible or not. But on cost part, we don't have any criteria. Like how do we know that my cost is more or my cost is less, or whether I should invest so much money on that particular project. So that's why this factor BC ratio, it suggests whether I should invest that much money into the project or not. So how do we assess this BC ratio? So it contains two parts: annual benefits and annual cost, benefit cost ratio. So in annual benefits, for irrigation benefits, first of all, the primary benefits are irrigation benefits. So how do we assess them? The net value of agriculture production in the area to be irrigated under pre-project condition. Okay, pre-project means the existing condition. What will be my net value of the agriculture production? Net means my gross value of the agriculture production minus my expenses. Expenses like seeds, expenses of seeds, manures, fertilizer, labor. These are the expenses. So I subtract these expenses to get the net value. In the similar fashion, we calculate the net value of agriculture production after the completion of the project. Okay, mean post-project condition. And difference of these two will give me the net irrigation benefit. So that's how we calculate the net irrigation benefit. Then if a project also have the drinking or industrial water supply component, and if there is specific reservation in the storage of the reservoir for the drinking component or industrial water component, then we have to exclude the portion cost of the drinking component from the total cost of the project. And that a portion cost of the irrigation component we have to consider, and irrigation benefits we have to consider for calculating the BC ratio. That apportionment of the cost, it is done by the cost appraisal directorate. They do this part, apportionment of the total. If we have the total cost of the project, they apportion the cost between the irrigation and drinking water or industrial. They apportion that. They have some other methods like variability method, flexibility methods. So cost appraisal, they will tell you more about this apportionment of the cost. So then alternatively, the quantum of water supplied to the municipalities, industries, it must be charged at the rates fixed by the government or agreed to the parties, amount be considered as benefit. So if my project, it has an industrial water component that it will supply water to the different industries, so we have to consider the benefits of that water component also into my total benefits. Then comes the pisciculture. So how do we calculate this pisciculture? If in case like the pisciculture is done by ponds, or that these ponds they are to be fed by the canals or this storage of the water, from the reservoir. Okay, then the benefits we have to consider for the total benefits. So the total benefits, they are calculated based on the average area. So area at the MDDL value and area at the FRL value. So we take the average value. In that area, we multiply by my output per hectare. So in the command, we have to see what kind of fishes they are available in the reservoir, so that the rates of those fishes we can take for calculating the benefits. So the state authorities, they have to get it vetted by the fisheries department, state fisheries department, and submit it to us for checking it. So it must be vetted by the fisheries department, then we consider it as a benefit. Then animal husbandry, if there are major farms or animal farms are there and they are also getting water from the same similar projects, so the benefits for those will also be added into the project. Then hydropower, if there is hydropower component is also there, so the apportionment of cost is done, like power component and the irrigation component. So if we are taking the apportion cost of the irrigation component, so we will take only the irrigation benefits and calculate the BC ratio. But if we don't have the apportion cost of the irrigation component and we are taking the total cost, then we will take the total benefit and our benefits will also be added up. Then catchment area treatment. For the catchment area treatment, like the procedure which we do for reducing the soil erosion, water levity, like for check dams or trenches we prepare. So the increase in yields are there. So these benefits then canal bank plantation, reservoir territory afforestation. These are also the benefits which are included in the 2010 guidelines, and we adopt these benefits in our BC ratio format. Then comes the annual cost. So estimation of annual cost. So these are the 4 or 5 components. Like first component is the interest at the rate of 10% on the estimated cost of the project. Estimated cost of the project including the cost of land development. So what is my estimated cost of the project? I'll add the cost of land development. So land development charges which we consider here is 20,000 per hectare of CCA. So this I will add it into my cost of the project, and then interest on that total cost 10% will be taken. Then O&M charges. So right now O&M charges are 1,500 per hectare of CCA. So these have been considered based on the Finance Commission report. Then the depreciation of the project. So depreciation is based on the life of the project. So if my dam is there, so we presume that life will be 100%. So 1% depreciation will be applicable. If barrage is there, so we consider the life of the barrage as 50 years. So we consider the 2% depreciation of the barrage. Okay. Then maintenance of the headworks. So maintenance headworks, we take 1% of the cost of the headworks. So this cost of the headworks is also vetted by the cost appraisal directive. So they give us that cost of headworks value, and 1% of that cost of headworks is considered for maintenance of the headworks cost. Then if my project has the lifting component also, okay, so if there is a lifting involved, so depreciation of the pumping system, rising mains, and power charges, these 3 components I have to consider also. So depreciation of the pumping system comes out is taken as 8.33%, assuming the life of the pumping system as 12 years. And for rising mains, life of the system is considered as 30 years. So depreciation is 3.33%. So this pumping system cost and rising mains cost, it will be given by the cost appraisal directive. So we will apply the 8.33 and 3.33 factor. And then from charges for power at prevailing rates. So for lifting the amount of energy units that will be taken by the project, the project authority will submit the total energy units that will be consumed annually for this whole pumping arrangement. So multiplying by these total number of units, annual units, multiplying by the per unit rate prevailing in that particular state will give me the total charges for. So now I will show you the BC ratio format. So this is the BC ratio format, which is given in the guidelines of 2010 guidelines. This is the pro forma for calculating the BC ratio. So there are components of gross receipts, expenses, then net value. So in the gross receipts, so this is before irrigation and after irrigation, means pre-project and post-project. So gross value of farm produce. Okay, then there is dung receipts at the rate of 10% of fodder expenditure. From where we get the fodder expenditure? Here it is, fodder expenses, 15% of the gross produce in pre-project and 10% of the gross produce in post-project. So these all are experimental values. These figures 15, 10, 2.7, 5, 3, 2, these all are given in the guidelines itself. Then on expenses part, we consider the expenditure on seeds, expenditure on manures, fertilizers, expenditure on hired labor, human and bullock. Then fodder expenses, which is considered as 15, 10. Then depreciation on implements. Then it is considered as 2.7 and 2.7 for both conditions. So depreciation is on implements, the tools which is used by the farmers on the field. So depreciation for those tools, that is 2.7%. And share and cash rent, 5 and 3%. And land charges are also 2%. So these are the values we consider for expenses. This is gross receipt. So net value we get by subtracting the gross receipt from total expenses in both pre and post project. For net agriculture annual benefits, we subtract the post project from pre project, then we get the net annual benefits. And if I have the industrial benefits, fisheries benefits, or drinking benefits also there, so we will add up these benefits into the net annual benefits of irrigation. And this is the annual cost, interest on capital cost, which I have already told you, and depreciation of the project, annual O&M charges. So 180 it was written, was earlier at the time of preparation of the guidelines, it was 180, now it is 1500. So maintenance of headworks, and depreciation, pricing, pumping and power charges. Then annual benefit by annual cost. This is how we assess the BC ratio. So these are these two appendices, F1 and F2. Which state authority they have to submit it duly signed by the Director, State Agriculture Department. Because all these appendices, it includes the agricultural values like yields of the crops, then prices, seeds rates, fertilizer rates, hired labor rates. So because that's why it has to be vetted by Director, State Agriculture in pre-project condition. In the similar manner, in post-project condition, so these F1, F2 appendices, they are very important for calculating the BC ratio. So they have to get it vetted by or signed by the Director, State Agriculture. Now, as per the guidelines, so the minimum criteria of BC ratio 1.5 is there. So for the projects where the BC ratio is 1.5 or greater than 1.5, only those projects are economically viable in normal condition. But there are some exemptions for drought prone areas, so relaxation has been given. BC ratio is 1 is considered acceptable in case of drought prone areas. So after this economic viability, so we have checked the technical feasibility, the economic viability. Both we have seen. So if both the project passes for both the criteria, then it is techno-economically viable. This is one example, but I will show you. Excel sheet is visible to everyone? This Excel sheet is visible?
No, sir.
No.
No, sir.
Is it visible now?
Yes, sir. Yes.
Yes.
Okay.
Yes, it is visible.
So this is the BC ratio for the same project, Bhuj multipurpose project, which we have calculated. So that's how these Excel sheets they have been prepared for both pre-condition and post, pre-project and post-project. Pre-project means existing condition, and post-project that the whatever the state authority they have proposed after the completion of that project. So in the pre-project condition, they have proposed for these crops. The total was 24,621 hectare. Okay, so maize, bajra, paddy, pulses. So these were the crops they have proposed. Then these were the yield values. Yields are basically in quintal per hectare. Yields of every crops they are different. So quintal per hectare, these are the yield. So total yields multiplied by area gives the total yield, then price of the crops. Then gross income by multiplying this total yield multiplied by price of the crops. Then same manner seeds rates. Then per hectare we find out the amount of the seeds. Then fertilizers, hired labor, then the net income. So these are the values of pre-project. Gross farm produce, this value. Then dung receipt, 30% of the fodder expenditure. Fodder expenditure is this much, 15% in pre-project condition. So 30% of that value is this dung receipt. Total is gross receipt. In the similar manner, we calculated the expenditure on seeds we have considered from this value, manure from there, fertilizer. Then we have put these ratios and assess the net agriculture benefit by deducting the receipts from the expenditure. This is the net agriculture benefit in pre-project condition. Similarly, we calculated the post-project. In the post-project, project authorities, they have proposed the area of 91,000 from 24,600 to 91,000 hectare in the post-project. So yields, these were the same. They considered, we calculated the gross receipts, same manner, and net value. So net agricultural benefit of irrigation is subtracting that net value in the pre and this value net in the post. This is the net value, subtracting those post and pre. So there, this is the value. So in this project, they proposed the drinking water, industrial water component also, and there was lifting component also included because some command was there in the upstream of the reservoir. So they were lifting the water from reservoir itself, directly from the reservoir. So drinking water they have calculated. So 18.92 MCM was the drinking water, proposed drinking water, and industrial water was proposed as 20 MCM. So we calculated took the rates of 11 rupees per kiloliter and assuming the 3 rupees per kiloliter for treatment and O&M charges for the drinking water supply. So we assess this benefits. Similarly, industrial benefits, then power. Then cost of project was this much, 11,000 crores. So land development charges were 20,000 per hectare of CCA. So CCA was 20,061. So interest on capital, 10% of these two values. So we added up these two values. So 10% of this value will be interest on capital. Then depreciation, because it was a dam, so 1% depreciation was taken. Then the O&M charges, that time 11,175 per hectare was there, so we took the charges as 11,175 per hectare. And O&M charges of headworks, 1% of the cost of headworks. Then pumping system rising mains, 8.33%, 3.33%. Then energy charges. So this was the annual cost. BC ratio came out to be 0.7879. So whether it will be economically viable project or not, can anyone tell me? My BC ratio came out to be 0.7879. So my project will be feasible or not, economically viable or not?
No, sir, economically not viable.
Yes, it is not economically viable because it is less than
Less than 1.
1.5 in normal condition. For drought prone it is 1, but it is less than 1 also. So the project was not approved at that time and the project was returned. So that's how we calculate these BC ratios. I've already shown you. So if you have any doubt on these two methods, like in irrigation planning, crop water requirement working tables, or these BC ratios, you can ask me. One more thing I would like to tell you that right now in our guidelines there are only direct benefits assessment. We are only considering the direct benefits. irrigation benefits and drinking water or these benefits. These are all direct, but we are not taking the indirect or intangible benefits because they are very we cannot easily easily assess those benefits. But one committee has been constituted and work has been awarded to NCAER, National Council for Applied and Economic Research. So it is also in the final stages. They prepared a report and submitted to us for assessing the indirect benefits also. So आगे हो सकता है we will also add the indirect benefits with the direct benefits in the guidelines. So we'll consider both direct benefits of the project and indirect benefits of the project. Right now we are taking only the direct benefits.
Sir, in the irrigation project, especially in the Gangetic Plains area, so nowadays, like monocropping or some like same type of cropping, especially like maize and all, they are cultivated in an extensive manner. So I think sometimes the soil quality is degraded. So while constructing and while preparing the DPR, the the soil, the condition of the soil is degraded. So anything, any parameter regarding this, that the soil quality is degraded, how to enhance the soil quality, means any cost is included in this setup?
Okay, so for improving the soil quality, yes, the project authority, they can propose that if the soil quality has been degraded in their command area, they can propose the measures for improving the soil quality of that particular command area in the project itself. Then the cost may be considered at that stage.
Yes, sir, I
But
think that is
recently, I have not seen projects like these, like if they are proposing something like that, because the projects which we are seeing here, they have diversified cropping pattern. We are talking about the cropping pattern like of same crops, like monoculture. Yes, but they can propose the improving soil fertility measures also in the project proposal at the designing of the project stage.
yes, sir, because generally it is seen that farmers want to cultivate only those crops which have a good economic value, and also
Yes,
they
cash crops.
they can survive the harsh conditions. Like maize, in maize, all the means right from everything is sold, and also it can withstand the extreme conditions. After the harvesting, also the waste products are also sold in the local market for burning and all other purposes. Sir, is there any project in which, suppose in modern technology, that apart from that, since it is an irrigation project, apart from the water from the canals, like cloud seeding may be included. So, is there any project where this parameter is seen or kept in mind?
No, cloud seeding they have not, but we are yes, we have received the modernization of the projects also. Modernizing projects like SCADA system, they have been considered in the projects along the canals. They are going for this SCADA system, like for automation of whole canal system by putting the sensors or like by putting the gates at all the outlets to the fields in a automated manner. And these kind of projects we have received here. One project was Gun Canal of the Rajasthan state. So they have proposed that modernization of that for one particular. It was a pilot project for around 1 lakh hectare. They have proposed it over a main canal. So they were doing the automation of the whole that main canal by putting these sensors at a particular canal sections or at every gates of the outlets. So they will supply the water based on the inputs from the farmers. Like farmers, they will give the inputs like because right now the Varabandi system is prevalent in many of the states. So rotation chart is prepared by the dam authorities, and they supply the water based on the rotation policy. But in this SCADA system or in this automation of the project system, the water will be supplied based on the demand of the farmer. If they have their demand on the field, then only the water will be supplied to that particular field. So it will also increase the water use efficiency, and that waterlogging problem in the head reaches of the canals will also be get reduced, because right now the in the head reaches the water gets logged, and in the tail reaches water does not conveyed. Water gets not conveyed there. So this problem could be solved by using that like automation of the canals. But cloud seeding, this kind of thing we have not seen here. Like nobody has proposed till now. We can see it in the future also. But cloud seeding part comes when there is deficiency of water. But if we have storage structure and we can provide the water in the lean season, then I don't think that cloud seeding is necessary.
In the project cost, the timely elimination of sediments, which may means if which is seen in especially in the unlined canals, the timely removal of sediments is also taken into account or not?
O&M charges, they have been charged at the time of BC ratio, but that O&M of the canals, it is rested with the state authorities. They must do this, but they are not doing it. That's why we are getting so much proposals of ERM of canals right now. If they are doing it in a properly manner or in a timely manner, then we'll not get any ERM proposal of the canals, but we are getting so much ERM proposals. So it is rested with the state authorities, and I don't think so that they are doing it in a timely manner. But they must do it, because due to the sediment deposition, the canals storage is like canals capacity is get reduced, and also it also affects the lining of the canal, which also results in increasing the seepage losses, and water use efficiency gets also reduced. Any other doubts? Okay, then we'll finish it here. So if anyone wants to have any doubts, or if anyone wants to clarify anything, you can contact me. So I am in irrigation planning node directed. So you can directly contact me or ask me. Thank
Then
you.
one more question was there.
Yes.
So recently, GeoCrop app is developed under CWC. So is there any connection with that GeoCrop and that irrigation IMO really?
No, we are not directly involved in that process. So POMIO is POMIO organization. They have prepared one tool, ET tool. So quick assessment of the water use efficiency of the projects. In consultation with the World Bank, they prepared one ET tool based on the remote sensing data. And in that remote sensing, in that tool, ET tool, so there was a limitation of crop classification, because by the satellite data, we were not able to classify the different crops. We know that whether that area is cropped or not cropped, or cropping is there or not, or whether there is crop, there is water. We can identify that, but we can't identify within the crops which crop is there. That we can't classify the crops. So for that purpose, that geo crop has been developed, so that crop signatures can be taken, and one libraries could be found of these like crop signatures, and that can be incorporated in that ET tool for that quick assessment of ET values. So POMIO is directly involved in that, but IP or IMO is not involved in that thing.
सर हो गया कंप्लीट देन?
हाँ कंप्लीट.
ओके, सो अगर पार्टिसिपेंट्स को और कुछ पूछना है तो पूछ लीजिए, अदरवाइज देन वी क्लोज दिस सेशन. Okay, so no more doubts. So thank you, sir. Thank you for delivering the two sessions on the topic of irrigation planning and irrigation management. And these two sessions were very enriching. And जो CWC का जो काम है प्रोजेक्ट अप्रेजल और उसमें क्या एक्टिविटी रहती है इरिगेशन प्लानिंग के रिलेटेड, उसके ऊपर आपने काफ़ी सरल तरीके से पार्टिसिपेंट्स को अपना एक्सपीरियंस आपने शेयर किया, अपना एक्सपर्टीज शेयर किया. And I am sure that these two sessions must be very enriching for the participants. So on behalf of National Water Academy, sir, I extend my gratitude for delivering these two sessions, sir. Thank you so much.
Thank you.